Okay, so number one, it says, what is the amplitude of the period? That's pretty easy. So number one, I'm going to graph it on a separate sheet of paper. 124.22. So first of all, number one, I know the amplitude is 3, right? And I know the period is this. It is 2 pi divided by the frequency, which is 3. That number is the frequency. B, and that's a question on your test. B is the frequency. But I don't want that. I want the period, which is just 2 pi thirds. Always 2 pi. Always 2 pi divided by the frequency is the period. Okay, so then if I know that, I'm going to do my axes a little bit different. I'm not going to go by pi halves, but I'm going to go by thirds, okay? So I know I'm going to have a width of 2 pi thirds, so we'll go pi thirds. Not pi halves, pi thirds. 2 pi thirds. 3 pi thirds. 4 pi thirds. 5 pi thirds. And 6 pi thirds. And I'll let you get caught up, okay? Now I'm going to do 2 graphs, because I'm going to shift it after I graph it. Lauren, ask your question, please.
Oh, no, I figured it out.
Now I know a sine curve, a plain old sine curve looks like this, but we're going to have an upside down sine curve, right? So this is the shape I want. I want this shape here. And I want it between 0 and 2 pi. I want this shape there, okay? And I'm going to go from 3 to negative 3. So I want this shape, so, I'm going to go, starts at 0, ends at 0, middle way 0. It's going to be upside down, 3 and negative 3. So I do my 5 points. It's just easier for me to do a dot to dot. Do my 5 significant points. And then I'm just going to trace it in. There's 1. I'm going to do it 2 more times because I have a frequency of 3. So I'll take this shape again. I'll put it between 0, 2 pi to 4 pi thirds. There. Okay. I'll do it again. There. Carly, that's nice to hear about Cameron. Glad to hear that. Okay, there it is, except we're never going to move it, right? So I'm going to move it pi force. And I have to estimate pi force because I went by thirds. So I'm going to go pi force forward. So that's about pi 6. So we're going to guesstimate pi force to be about 3 squares, okay? It doesn't have to be perfect. We're going to move about 3 squares, all right? That's pi thirds. That's close to pi force. Close enough. I can live with it, okay? And we're also going to take this thing, we're going to move it down 2, right? Down 2 squares. So every important point is going to go over 3 squares to the right and down 2. So 3 squares, 2. There's 1 point. 3 squares, down 2. 3 squares, down 2. 3 squares, 2. And pi force, down 2. Pi force, down 2, 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 force, down 2, pi force, down 2. Okay, I'll wait for you guys to get caught up. And I'm just going to, let's see here. It's right there, right there. Oh, I missed one, didn't I? Yeah. Wait a minute. 2, 3, 2. Oh, there's that one. There it is. There it is. Okay. Thumbs up? Okay, let's look at number 2. Okay, what is the equation of this periodic function? So, gosh, I'm probably going to call it a cosine. I mean, if I call it a sine, it might start, I'm not sure. It might start there, but I think I'm going to call it a cosine because I can find the max. I could call it a negative cosine start here. Yes, Lauren, totally right. They're both the same answer, right? So I'm going to start with cosine. Lauren, if you want to do negative cosine, that's absolutely great. I'm going to go y equals, we'll just put cosine, right? Now, to find the amplitude is always the max. Let's see, 1, 2, 3, 4, 5, minus the min, minus a negative 1 divided by 2. The amplitude is always max minus min divided by 2. Or if you can find the middle of the curve, you can see it. I think the middle of the curve might be, let's see, go up 1, 2, 3, right about there's the middle of the curve. But sometimes it's hard to find the middle of the curve. Thank you. So I got an amplitude of 3, so I'll put my 3 right there, okay? Now I need to find the frequency, which is b, and b is 2 pi divided by the width. Divided by the width. Well, okay, let's figure out what the width is. Let's see, if I go from, probably from here to here would be the easiest to find, right? One ride from here to here. Let's see, it looks like it's maybe 8. It looks like 8, doesn't it? It looks like it's 6, 7, negative 1, so I think the width is 8. So then my frequency is going to be pi force, okay? So I'm going to put pi force here, okay? It has been shifted. So Lauren, you're going to have a plus 1 if you used a negative. I'm going to have a negative 3, I think, right? 1, 2, 3. I'm going to put an x minus 3 because I did a horizontal shift. And Lauren, you do a x plus 1, right? And then finally, I see the whole curve's been moved up 2. So go plus 2. But if you can't figure this number, okay, this number is always going to be the amplitude plus the minimum if you can't figure out that number, okay? So the amplitude's 3, the minimum is negative 1, that makes 2, okay? That'll always work, okay? All right, I'm going to need a separate sheet of paper on this stuff because it takes some work to do 3, okay? So I'm just going to do all of these on a separate sheet of paper just because it takes some work. All right, so number 3. I've got a sine A minus 1, sine A plus 1. So I tried to put the ones on the test that were not that difficult, okay? Hopefully we see it. If we multiply, we'll get a sine squared. 1 sine minus a sine of A and minus 1. So if I FOIL it out, sine squared of A plus a 1 sine of A minus a 1 sine of A minus 1, right? Which these two middle terms cancel, and you're left with a sine squared of A minus 1. Now, 1 minus sine squared of A is equal to a cosine squared of A, right? That's an identity. We have just the negative of that. We really do. What we have is truly a negative 1 times 1 minus a sine squared of A. If I take out the negative 1, which really makes this identity a negative 1 cosine squared of A. Does that make sense? How I reversed it and I got the negative, right? Good. Some kids have a really hard time seeing that, but I can show it. There's negative 1 and a positive sign. All right, let's look at 4. I'll put 4 right here. I've got a tangent x plus a cotangent x over a secant squared of x. All right, this one's just going to be a whole lot of fractions, but I can do it, okay? Whole lot of fractions. So sine over cosine, right? Sine of x over cosine of x plus cosine over sine. All over 1 over cosine squared of x. And I'll let you catch up, okay? It is really, because I want to get everything in terms of sines and cosines. So it's kind of a pain, but I want a common denominator here. So I'm going to multiply this one by sine over sine for common denominator. cosine over cosine, okay? So let's see what I get. I will have sine squared plus a cosine squared all over sine cosine all over 1 over cosine squared of x. And I'll wait. So I got my common denominator. I combined them. I like sine squared plus cosine squared. That was my goal. Was it sine squared plus cosine squared? Because that's 1. Right? So I have 1 over that, and then I'll invert and multiply. But I'll wait for it before I do it, okay? So this is 1. So let's see what I have. If I scoot all of this down over here, I'll have 1 over sine of x cosine of x. And I'm going to invert and multiply too, right? I'm going to invert and multiply, right? Cosine squared of x over 1. Now it's getting easy, huh? A cosine for a cosine. Cancel out one of these cosines for one of these cosines. I'll have a cosine of x over a sine of x, and that is just cotangent, right? You guys are getting to know these, aren't you? You are getting to know these. Okay, whisk this away. Okay, now let's look at number 4. Number 4, I'm going to solve, or number 5, my bad, 5. 4 tangent x plus 3 equals 0. And I'm doing everything in terms of radians, 0 less than or equal to x less than 2 pi. So minus 3 divided by 4, right? I'm going to need my calculator in radian mode. Calculator. You guys get caught up. Okay, mode. I'm in radians. I like that. Okay, quit. So tan inverse, right, of negative 3 divided by 4. And this answer I can't take because it's not between 0 and 2 pi, right? So I'm going to spin it around the circle by adding 2 pi. And my first answer is about a 5.64, okay? x1, 5.64. And I also know that the tangent values are 180 degrees from each other, right? One's here, one's there. It's always that way with tangent. So x2 is just going to be by 5.64 minus pi. So minus, and I get about 2.5. Yeah, close enough. 2.5. There you go. Don't worry about rounding if you're close. You know me, I don't care about rounding. There are some classes in college, just depends on the professor, right? I'm not worried about rounding. If you get close, you're good. All right. 6. Am I going too fast? Okay. 6. Cosecant squared of x minus 4 equals 0. Plus 4 cosecant squared of x equals 4. Square root, right? Square root. 2 answers. Square root, 2 answers. Cosecant of x equals plus or minus 2. 2 over 1 because I want to flip it, right? So let's just go straight to cosecant of x equals a positive 1/2. Oh, I'm ahead of myself. Thank you, Lord. See what I'm already ahead of myself, aren't I? And negative 2, but you know, now I'm going to go to sine negative 1/2, right, Lauren? I was ahead of myself. Or sine of x equals 1/2, and sine of x equals a negative 1/2, and that's all over the unit circle, right? So if you look at your unit circle, pi 6 and 5 pi 6, 7 pi 6, and 11 pi 6. Okay, go ahead and check it out, but believe me, those are my radians, okay? And the unit circle's so much easier. I mean, you can get a decimal answer of this, but, you know, if it's on the unit circle, bam, there they are, right? Okay, let's look at 7.
And then could you put those answers back there?
I sure will, Ellie. Sorry about that. There it is. Okay. That's another way. 7. 2 tangent square root of x equals 3 tangent of x minus 1. All right, so let's bring everything over. So it's all in terms of tangents. Let's bring it all over because I'm going to factor. But first, let's get them together. 2 tangent square root of x minus 3 tangent of x plus 1 equals 0. All right. It doesn't hurt to see the algebra, right? 2x, x, minus 1, right? Right? You guys okay with my factoring? So let's bring back the tangents. 2 tangent x minus 1 and tangent of x minus 1 equals 0. It's pretty similar to our warm-up, isn't it? Not exactly the same one, but close. Mini equations, so I get 2 tangent of x minus 1 equals 0 and tangent of x minus 1 equals 0, right? Tan of x equals 1/2. I'm going to need my calculator. That's not on the unit circle, so tan inverse 0.5. So first angle is 0.463, blah, blah, blah. Second angle is going to be that plus pi. So add pi to that. So my second angle is 3.6. Tangent equals 1 is on the unit circle. I like that. Pi force, 5 pi force. All right. Okay, and I'll do number 8 when you're ready. Okay, gone. Okay, number 8. Tangent squared x equals tangent of x. Don't divide by tangent. You're going to lose a value. What we're going to do is common factor. But before we common factor, we're going to bring this to the other side. We'll bring the tangent over to the other side, and then we'll common factor. Okay, so I'm going to bring the tangent over, bring them together. I get a tangent squared of x minus a tangent of x equals 0. Okay, so by bringing them together, I can common factor out a tangent, and then have 2 mini equations. I'll put a 1 here so I don't get confused. I do want a 1 there. I like the 1 there. Common factor out a tangent, because that's what they both have in common, is my tangent. So I common factor out the tangent of x, and I'll have, well, a tangent of x minus 1. Mini equations, tan x equals 0, and tan of x minus 1 equals 0. This is on the circle 0 and pi. 0 and pi. Gosh, this one keeps popping up. We know this one. Pi force, 5 pi force, yeah. And then back to the tide problem, huh? Yeah, we're going to know how to do this tide problem, aren't we? All right. So I'll go through the tide problem with you again. So the first thing, let's go ahead and do a 24-hour clock. Okay, so I'm going to do a 24-hour clock on here for sure. Let's see what we got. High tide at 2 o'clock, 7 feet. Oh, wow, 7 feet, that's a big tide. 1, 2, 3, 4, 5, 6, 7. Oh man, it's way up there. Okay, high tide, but it's at 2 o'clock. So, right. Come on. Alright, so 2 o'clock. Do a high tide. 1, 2, 3, 4, 5, 6, 7. And a low tide, 11 o'clock is -2. That's a big tide. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 o'clock. And that was -2 feet, right? I think, and I'll wait till you guys are ready, but for me, what I do is I just like to do something like this. This is 9 hours, right? I like to draw that in because I know the length in time is 9 hours from high tide to low tide. So then I know I'm going to go another 9 hours to go to the next high tide, right? So I'm going to go to 20, right? 11. So I'm going to add another 9. So 11, 12, no, 9, yeah, 20, right? 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so there's my next high tide right there. Okay, and I can just sketch this in. There are places in the world where the tides are pretty extreme. The Bay of Fundy, I think they said it's something like 20 feet high. Crazy, huh? Okay, so now I know my period. I do. I know my period for sure. The period is 18, right? So I'm going to start with a y equals a cosine. And the amplitude, again, if you can't figure the amplitude, it's always max minus your min divided by 2. Max minus min divided by 2. Okay, so that's going to be 9 over 2, or 4.5. B, which is the frequency, is 2 pi divided by the width. Well, the width is 18, right? Frequency is going to be 2 pi divided by the width, so I can make that, I can reduce that to pi ninths, I suppose. I start at 2 o'clock, so x minus 2. Now the whole tide has been moved up. How much? What is this number? Well, this number is going to be the minimum plus the amplitude. Okay, so the minimum we know is -2, and the amplitude is 4.5. So this number is going to be plus 2.5. There's my equation. Now finally, to put in 8 o'clock, I'm going to put 8 o'clock right there, right? I'm going to put an 8 right there, 8 o'clock right there. So on my calculator, a couple of things, make sure you put, radians. I've got to make sure I'm in radians to do this. And to make it easy for me, this is what I like to do. I'm going to take this pi ninths and put it in my calculator. So there's my decimal, there's my pi ninths, right? So I'm going to go 4.5 cosine, answer, because there's my pi ninths. And then if I put in 8, it's really going to be 6. 8 minus 2 is 6. So if I could just go times 6, I'm trying to make it easier, so I don't have to use a bunch of parentheses, right? I'm trying to simplify what buttons I push my calculator. So 6, and the reason it's 6 is because I put an 8 right there, plus 2.5, and I can answer about 0.25. Okay, so yeah, 2, 3, 4, 5, 6, 7, 8. Yeah, actually my drawing's not bad. 0.25 could be correct, right? It's right there. Okay, so there's a couple other things I didn't quite do or go over on the review because it's also, I've got a little tiny homework assignment for you, but there's one problem in particular, I'll tell you which one I want you to look at. That's the important one.